after creating this second part, if you want to practice, you can just clone my repository and
Yeah. Okay.
Alright, so you can see the screen, right?
Yeah, we can see it.
Alright, cool. So
Just open up that another tab. So the owner of the company can come here if they want to pay the employees. They can add new employees, so they can click on add employee section right on the left side, and they can add an employee by adding their by adding their address, and then they can select if those employees an intern, junior, or senior, right? And in a smart contract, we have defined that if the employee is intern, their salary would be this. If the employee is junior, their salary would be this. So that is on our back end. On the front end, just the owner just have to specify the address and the position of the person, and that way they can add an employee to their company, right? And if they want to pay the employees, they can come to the pay salary tab on the left side, Ajay. And they can just click this button pay salary, and it will automatically pay that amount of ether to everyone. Let's say we have said that the interns that the salary for the interns is 1 ether, right? So it will automatically pay all the interns 1 ether. And we have said if the salary for junior is 2 ether, so it will pay all the juniors 2 ether automatically by just clicking one button, right? Yep, so that's it. And you can now go to remix, Aljay.
or
And here we have the code for this for this app, right? First of all, Aljay, can you try to run this code in the deployment section so that everybody can see how it runs on Solidity here in remix? Just deploy it. Okay, pass some ether
or
actually.
how much ether? How much?
Yeah, ether. Let's say 10.
Or
Okay, so our in this case, our constructor is a payable function. We have a payable constructor, right? So that means on the time of deployment, we can pass some ether to our smart contract. That means our smart contracts now holds 10 ether, right? Just expand this salary management, LJ. And then here you can see we have a function called get contract balance. So just click on that button. So yeah, it's showing that our smart contract has 10 ether as a balance. It is in it's showing in way right now. So now our smart contract has 10 ether, and from that 10 ether, it will pay to all the employees. Now let's just add an employee to our company. Just expand this add employee function. Yeah, add the address of the employee and also the position. So in this case, the employee position is an enum, and as you know, enums are stored as events internally. So we have three positions which are intern, junior, and senior. So for intern, the actual value would be 0. For junior, it would be 1, and for senior would be 2, right? So no. Okay, just try to transact it. Try to transact it. It will fail, right? Because only the owner can add some employees to our company, not anyone else. So just go above and change to your owner, and then add this employee. Now you can see that the employee is added to our company. So right now we have one employee who is an intern, right? Now let's add another employee. Let's add the third one, LJ, and make it junior.
or oh, my bad.
Okay. Yeah, and you have to change that too. Yep. So we have two employees in our company right now. One is an intern and another is a junior. So that means now if we pay our employees, right now we have 10 ether in our smart contract, and now if we pay our employees, we should have 7 ether left, right? So 1 ether would be sent to the intern and 2 would be sent to our junior. So just click on pay employees. Okay. So now just check the contract balance. it's 7 ether now. And when you go above and check all the accounts, you will see the balance will be updated there to them. So now this one has almost 101 and that 102, because they don't have 0.0001, because LJ tried to he tried to add employee uh, with those wallet addresses, but it didn't go through. So Kushagar, you wanted to say something?
I think I thought it
Your voice is breaking, Kushagar. I don't know why.
nothing. I thought that you are sending it in 0.1 ether because I sent it 0.
Oh,
It's
no,
1 year.
no.
No problem. No.
It's actually my version of the smart contract.
Yeah. Got it. I got it.
Yeah. So yeah, that's pretty much it. The owner can add employees, they can pay the employees, and yeah. So let's just start from line one, right, on our contract code. So we have the license on the first line, which is our MIT license, so everyone can use this code. And then we have the compiler version, right? So, and then we are just declaring that we need to create a contract, and the name of the contract is salary management, right? So here we are declaring some state variables now. um, let's start from the enum part. Because I think that would make more sense. So first of all, we are declaring an enum, right? Enums are we declare enums for a variable when we want to have some predefined values for that variable. For example, here we want the position to be only either intern, junior, or senior, right? We don't want any other position here. So we have predefined these three values, that we only want intern, junior, and senior. That's why we are creating this position enum. Yeah, so this is our enum. And then we are also creating a struct, that means our own data type. It's kind of like our own data type, and this struct is called employee, right? And this struct contains position. As a first argument, it will take a position, which is an enum, right? And we are calling it position. And as a second argument, it will take a uint, which will be called salary. So this is our struct. Now let's move on to our fifth line. So what we are doing is we are storing LJ on fifth line. Yes. So we are creating a mapping from address to employee, right? We are going to store all our employees in a mapping which is from address to employee. That means the employee from employee's address to the position and the salary of the employee, because that employee struct contains the position and salary of the employee, and in our mapping it would be mapped from their address to their position and salary. So yeah, this is our mapping. It is public and it is called employees. And on the sixth line we also have an array of addresses. So this array will contain the addresses of all our employees, right? That's what it is. And then we have this constructor on 17th line, and the constructor is payable because we are adding some amount of ether on the time of deployment, right? We want the smart contract to have some amount of ether, so that it can use that ether pay to other accounts, to the employees of our company, right? So yeah, that's why our constructor is payable. And in our constructor we are setting the owner to be message.sender. That means the person who deployed the smart contract uh, is uh, is is going to be the owner of our smart contract, because the constructor function is called immediately after the deployment of the smart contract. So this means, first of all, on line 8 we have defined a variable address owner, and we are setting this owner to be message.sender on the time of deployment. That means uh, the address who deployed the smart contract is the owner of our smart contract. Now we are also making a modifier called only owner, because we want these two functions, add employee and pay employees, to be only called by our owner, right? The owner of the smart contract. So why don't just create a modifier instead of adding require statements in both the functions. So we are making this modifier called only owner, and in this modifier we are checking that the owner should be equal to message.sender, right? So yeah, that's what we are checking in this modifier. And then let's come over to our add employee function, right? So this function is used to add an employee to our company, right? I mean, to a list of all the employees. So this function takes two arguments. The first one is an address, which would be of the employee, that is employee address, and the second one is the position, which is the employee position, right? And this first address is going to be payable because we want to pay to that address, to that employee address, when we call the pay employees function. And the position, and it also takes an enum. The second argument is an enum, which is of the type position, and it's called employee position, right? So this is what we are doing on our front end. We are adding, if you can go to another tab, LJ, we are just adding the address of our, in our add employee section, we are just adding the address of our employee. And in this section, intern, junior and senior, if the person selects intern, we just send 0 to our smart contract through our front end. If he selects senior, then we send 1. Also, okay, sorry, if the person selects intern, then from our front end we send 1 to our smart contract as the second parameter, and 2 and 3, so on. Okay, let's come back to our smart contract. So yeah, it's going to be a public function, and only the owner can call this function, right? Okay, so in this function we are defining a variable called pay. This is going to be a local variable, right? It is going to be of type uint. And then what we are doing is we are checking if the employee position is equal to position dot intern. So position dot intern is going to return us 0, right? And employee position, we are checking that if the person has supplied 0, that means the person wants to add an intern, right? If this is the condition, then the pay would be equal to 1 ether. Else if the position is equal to position dot junior, that means if the person has applied 1 in the function as the second argument, then the pay is going to be 2, because in that case the person wants to add a junior. And if both these conditions fail, then we know that the person is senior, right? So the pay would be 3 in that case. Okay, so after that what we are doing is we are defining an employee struct. We are defining a new employee variable, which is going to be a struct of type employee, and this is we are defining in memory. And this is going to be equal to employee of employee position that the person has applied, and the pay that we just found out from this if else statements, right? So yeah, this is going to be a struct, and it's in the memory right now. And then what we are doing is we are just adding it to the mapping and to the array as well. So we are saying employees of employee address, that means the address of the employee is equal to new employee, that means the struct that we just created. So it will map the employee address to the struct of that employee in our mapping. And we are also adding that employee address to our list of all the employees, that means to our list of all the addresses of all the employees, right? So yeah, that's what we are doing in this add employee function. I hope it's clear to everyone. You can ask any questions if you have any doubts. Okay, let's move on to our pay employees function. And in our pay employees function, it's going to be a public function, right? And it's going to be payable because we want to pay our employees in this function, and it's only going to be called by the owner of the smart contract. That's how we use the modifiers, right? And in this function we are running a loop. We are saying for uint I is equal to 0, so we are defining a variable I, and we are setting it to 0. And then we are saying while I is less than all employees dot length, that means in our all employees list we have the addresses of all the employees, right? So we are saying while I is less than in all employees of length, run this loop, and after each iteration just add 1 to I, right? That's how loops work. And then in this for loop we are just what we are doing is we are saying bool sent is equal to payable of all addresses of I. So all addresses is our list which contains all the addresses of the employees, right? So we are just saying we have to just convert it into payable first. So we are saying payable of all employees of I. So let's say we have a list of 10 addresses. So if the first time I is equal to 0, so we are picking up the first address from the all employees list. All employees of I would be the first address. We are setting it to payable so that we can pay this address, and then we are calling the dot call function on that address, and the value would be the value that need to be sent to that employee would be employees of, that means employees are mapping employees of all employees of I, that means all employees of I will give us the address of the person to whom we need to pay, right? So and then employees of all employees of I will give us the struct, right? So that struct dot salary, that means this would be the salary that we need to pay to that person. So we are just supplying, we are just sending that amount of salary to the person, and then the sent variable will contain the value true or false. If the value was sent, then it would be true. If it was not, then it would be false. And then we are requiring that the value should be sent. We require that it should be sent, otherwise the transaction will revert and the function will fail. Yeah, so that's all our that's what our pay employees function is doing here. It's just sending the amounts to all our employees. If it's an intern, then it will send 1 ether. If it's a junior, then it will send 2 ether, and if it's a senior, then it will send 3 ether to all the employees with just one click. So yeah, and then in our function, then we have another function which is get contract balance. This is just a helper function we are using to check the balance of our smart contract. And in this function we are just returning a uint, which is our address of this dot balance. So address of this returns the address of this smart contract, and dot balance means the balance of this smart contract. So yeah, that's what this function is returning. And in the last we have these two functions which are receive and fallback. So first of all, let's understand why do we actually need these two functions. So right now we have 10 ethers in right now we have 7 ethers in a smart contract. If you can come to our deployment tab, LJ. So okay, let's say we already paid the people for the first time, right? For our first month, we paid them. They already have, so we transferred 3 ether to them. Okay, I'll just transfer once more. Let's say the payment for another month comes, and you pay the employees once again. Just click on pay employees. No need to add another employees or anything. Okay, you paid the employees on the second month, and then okay, let's click on get contract balance. Now we have 4 ether left in our smart contract, right? Okay, let's say another month comes in. Let's say it's the payment for April now. Let's pay employees once again. Okay, this one also passed. Okay, now let's say the May month comes in. The May month comes in, but we only have 1 ether left in our smart contract now, right? And we have the required amount of ether that needs to be sent is 3 ether, but we have only 1 ether in our smart contract. So what do we do now? In the starting, we added 10 ether to our smart contract on the time of deployment. But how do we add more ether to our smart contract now, right? So that's why we need these two functions. These two functions actually allow us to receive payments in our smart contracts. Like when you go to your MetaMask, you cannot just type in the address of any smart contract and send ether to their smart contract. It is not allowed by default. You need to add these two functions to your smart contract so that others can just go to their MetaMask. They can put in your contract balance, and they can send the ether to your smart contract. So by using these two functions, you will be able to add more ether to your smart contract so that it can function correctly. It can pay the salaries to the employees. And yeah, so that's basically the function of these two functions. But if you want to know more about these functions, so basically the fallback function is actually called whenever someone calls a function which does not exist in our smart contract. That's when this fallback function is called. And if we have some data, if we have some message dot data, so actually during the transaction you can also send some data to your along with the transaction. So if you go to that site, LJ, can you go to rect.news, rekt.news?
Wait, say it
And
again.
then just open up another tab and go to the site rect.news, rekt. Yeah, that one which I mentioned a couple of days ago, I guess. And if you go to okay, Casio one, the Casio rect. Yeah. And scroll down. If you see, okay, just scroll down. Okay, above. I'm sorry. um So basically, what I was trying to show you guys is that you can also send a message along with the transaction, and this was actually a hack, and the hacker sent a message in the transaction. They said that all the amount of ether that they like stole would be sent to the charity. So that was their message in the transaction. Um, can you find any transaction hash here, or any ether scan address, because I saw that.
Oh, let me see. Let's see.
Actually, I tweeted about it. I tweeted about it. You can, okay. Let me just send you the link to that, because I have included the.
Find the
Oh,
source.
here's the address. Here's the address.
Got it.
Here's the address here.
Okay, so oh no, this one is for them. This
Oh,
one
never
is to
mind.
donate
That's
donate
donated. My
You
bad.
can go up. I could see some soul address was mentioned. Yeah. Please follow me.
Yeah, there it is. There it is. Via transaction input data. Click on that transaction input data.
Oh, my bad.
No problem. So yeah, if you just scroll down and click to see more here, yes, and if you see, this is the input data, and if you view it as UTF-8, and you see, this is the message that the hacker sent. He said account with less than 100k have been returned. All the money will be donated to the charity. So he said that the accounts which had less than 100k in their as their balance, so he returned their funds, and all the money that he has left will be sent to the charity. So you can send a message along with the transaction, right? So in case the message dot so let's just come back to a smart contract now. And in case the message dot data, that means the data is empty, then the fallback function is called in our smart contract. And if in case the message dot data contains some value, then the receive function is called. This might not make much sense to you right now, but if you want to just go deep into this, if you want to know more about this receive and fallback, you can refer to this YouTube video. Very good video. It explains it very well. Let me just send the link to that video in the pair programming chat. But for now, just understand that we are using these functions to just let other people send some amount of ether to our smart contract, so we can refill it with ether so that it can be used to pay to our employees, right? uh,
Just
Please, a question.
Yeah, LJ, what were you?
It's a question. I have a question.
Yeah, I'll let him. I'll let you answer the question, Sahil.
What did you say, LJ?
I said I'll let you answer his
I wish to
question.
ask. Yes.
Okay, what was the question?
Yeah, which address would they use to send ether to your contract?
Smart contract. So yeah, you will send the ether to the contract address. So in Solidity, our smart contracts also have addresses, right? They are you can actually fill that address on Etherscan and it will show you your contract. So contracts also have a they also have an address in Solidity. So you will just put in that address and send that amount of ether.
And also, I'm sorry, you could keep talking. My bad.
Okay. Then on the constructor, we assign the able to it. So when you send that 10 ether, it's being sent to the smart contract address or the person's address who deployed it.
So in this case, the ether is sent to the smart contract, right? Ether is a payable function. So whenever you call any payable function, not only the constructor, you can send some amount of ether. You can pass message.value, and that value will be sent to the smart contract. In that case, you don't need to fill in the like contract address because you are already calling that function of the contract, right? So you can just directly send any amount of ether to the smart contract. So that's what I was going to show next. If you just scroll down, LJ, and we have this function accept payment, which I have commented out. So as you can see, this is a payable function, but it does not contain anything inside it. Can you just uncomment it, LJ? Um, yeah, so this is a function called accept payment, and this is a payable function, but we do not have any code block inside it. It is just a function which is payable. But in this function also, you can specify some amount of value, and you can just call this function, and that amount of ether will be sent to the smart contract. So that's what I'm trying to show. In any payable function, you can just directly send any amount of ether to the smart contract. If you just redeploy the smart contract and yeah, if you just redeploy this smart contract and call this function accept payment, it will transfer that amount of ether to this. Okay, check the contract balance. Check the contract balance. Right now it's 0, right? And if you supply a message that value there and call the accept payment, let's say 10, and accept payment. Now check the contract balance. Now you can see it is 10. So you can directly supply any amount of ether in a payable function. You don't need to do anything else. Is that clear, Jix?
Yes, it's clear. Thank you.
Yeah, you're welcome.
And also, just to show that this actually has a contract, even though this is not on the EVM, you can hit copy, and I'm gonna just comment it. I'm gonna paste it, and boom, as you can see, this is the contract address of this current salary management smart contract. And also, if you want to use receive or the fallback function on Remix, what you will do is that say I want to send 5 ether to the contract, right? What you will do, say if I actually didn't have this function, say if this function actually didn't exist, what you will do is that you will hit this button here, transact, and as you can see, it has 5 more ether. So that's how you use these functions here on Remix. But then on MetaMask, you would specify what address. MetaMask is different. Basically, it's basically how it's similar to how you would just how you would transfer ether to like somebody's like a friend that you might have send ether to them. So
yeah, and also you can supply the message data here in the call data section. in the input field you can supply a hex value, which would be the message data that we were talking about. The message that you can send along with the transaction. So you can supply a hex value here, the hex value of your message, and you can transact that, and it will be sent along with the transaction, as we just saw there. The hacker sent that message. So he actually supplied the hex value and he transacted it and all. So yeah, this is a salary management smart contract. Actually, I just walked you through the code. I didn't write it because I was having some network issues. So that's why we are done early today. It's like 9:45 a.m. here in India. So we have 15 minutes left. You guys can ask questions if you have any questions. Otherwise, we'll wrap it up for today. I hope it's clear to everyone. The salary management smart contract. I will also push the code to the GitHub repo. Actually, I will just push it right now. So yeah, if anyone has any questions, they can ask. Okay, I don't think so.
Well, looks like that's it. If nobody has any questions.
Yeah. So thank you everyone for joining today. I'm gonna push the code to the GitHub right now, and you can refer it there. Yep. See you tomorrow. Bye.
Well, not tomorrow is a break. But
Tomorrow is
yeah,
okay.
yeah. Tomorrow we not we resume
Tomorrow
Monday.
also.
Monday for you guys. Monday for you guys. Yeah.
Yeah, Monday. So tomorrow is actually Sunday. So it's off for tomorrow, and we'll see you on Monday. According to Indian Standard Time. Yeah. Okay.